Good afternoon and welcome to today's webcast, sponsored by Schmersal. My name is John Hedge, Senior Writer with the New Equipment Digest. Before we begin, let me explain how you can participate in today's presentation. First, if the slides and audio are not responding, press the F5 key to refresh the webinar console. The toolbar at the bottom of your screen includes a help icon if you require further assistance. We welcome your questions during today's event. To submit your question to today's presenters, simply type into the Q&A window on the left side of your screen and then hit the Submit button. We'll be answering as many questions as possible during the Q&A session that will follow the main presentation. Today's session is being recorded and will be available on the NED, EHS Today, and Machine Design websites within the next week for you to review. You'll be notified by email when the archive is available. On your console, the Schmersal logo is hot-linked. If you want to visit their website during the webcast, you can click on a logo and a new window will open. This will not take you out of the webinar. I would now like to welcome our speaker. Mike DeRosier is a TUV certified functional safety engineer for machinery. His 20-plus years of experience include controls engineering to design, build, and integrate full machine control systems. His safety experience led him to help corporations to develop corporate safety standards, perform machine safeguarding risk assessments, machine safety training and design, as well as implementation of safety systems for all aspects of machinery, including electrical, electronic, pneumatic, hydraulic, and mechanical systems. Welcome, Mike. The floor is yours.
All right. Thanks a lot, John. Appreciate it. Well, hello, everybody. Glad everybody was able to join us today to talk about this subject, which particularly in the U.S., it's a very hot topic, very controversial subject of dealing with lockout tagout versus machine guarding. Unfortunately, what we find a lot of times is there's a thing about one replaces the other, and that's the thought process. Lockout tagout replaces machine guarding and always should be done that way, but the other thought process is, well, I really can't run the machine. If I lock it out, it has to be machine guarding. In all reality, even though the title is lockout tagout versus machine guarding, because that's the thought process, we want to put that together. We want to talk this afternoon about how lockout tagout and machine guarding work together to be effective safety in all aspects when we talk about personnel safety and machines. And we're going to break into that in a couple different aspects with it, where we're going to talk specifically lockout tagout, we'll talk specifically machine guarding, and we'll talk about a hot topic in between referred to as alternative lockout, and we'll hit that toward the end. As John indicated, I know there may be a lot of questions that get posed throughout the course of this webinar. Please fire away. We'll do our best to answer everything we can during the webinar and then the Q&A afterwards. Whatever we don't get to, we'll definitely respond to any questions that were out there as soon as we possibly can. So lockout tagout versus machine guarding. We know we need both on equipment, but the issue comes down to when do we use one or the other? How do we use them in conjunction with one another? How do we make this effective and work for what we're trying to do? The hard part we run into, and unfortunately this is why it tends to get controversial in the U.S., is trying to interpret the OSHA law, the OSHA guidelines, and what they're stating. And in particular, when we talk OSHA, lockout tagout is part of what's written into law, is in 29 CFR 1910.147. That's the control of hazardous energy. I'm not going to read verbatim from the slide. Everybody can do that. I'll give you a few seconds to read that as I'm talking. But the next couple of slides we're going to be talking about and trying to break down what OSHA is really saying. Now, there's going to be a lot of interpretation. You're going to find interpretation letters. I'm hoping after today we'll clear up some of that subjectiveness and cloudiness and help you as companies or people within your companies put proper procedures and processes in place to follow what you need to do legally, as well as what is practical when it comes to machine guarding and how to work and interface with the equipment. So when we look at the scope of the Control of Hazardous Energy by OSHA guidelines, I'm going to highlight a few points. What is Lockout Tagout really supposed to do? The key points in that scope is servicing and maintenance of the equipment require Lockout Tagout. It has to prevent the unexpected startup or power up related to the equipment, as well as the Lockout Tagout procedure needs to accommodate the ability to release stored energy. They're the keys to the scope of supply when it comes to Lockout Tagout and a proper materials, components, processes, and procedures as a result. In the next slide here, when we look at the application and the definition of the application of Lockout Tagout, and I know we may have several attendees from other countries outside the U.S., a lot of the principles follow the same suit, but I'm going to refer more to the U.S. when it refers to OSHA law and federal legislation. So here in the application, again, more words and what does it really mean when it comes down to it. I'm going to highlight this for you. They distinctly state in the application of the standard that normal production operations do not fall under Lockout Tagout. When you look at service and or maintenance, which takes place during normal production operations, it's covered by the standard only if the following criteria: you're removing or bypassing guards or any other safety devices. You're removing that safety device. So when you try to define that is, if you're removing a fixed guard from a machine, it's not bolted to a machine preventing you from getting into a hazardous area, the moment that you're removing a fixed guard, you should be applying Lockout Tagout. Or if you're bypassing a guard, Lockout Tagout should be applied, but not normal production. So if an employee is required to place any part of his body into that area, it applies during a machine operating cycle. And then at the bottom of the slide there, I gave you some additional clarification on what the normal production operations definition is and what is considered service and or maintenance activities. In continuing with the application aspect, there are exceptions. And again, this is directly out of 1910.147. What do we mean by exceptions? I highlighted most of this paragraph. Minor tool changes and adjustments or other minor servicing activities which take place during normal production operations are not, and I capitalize not, covered by the Lockout Tagout standard if they are classified as being routine, repetitive, and integral for the use of the equipment. Here's where a lot of our problems and controversies come from, and here's where you see different interpretation letters regarding this and discussions on boards and forums. Ultimately, every company has to clearly define in their processes, in their SOPs, clearly define what is routine, repetitive, and integral to the use of the equipment that's being used. Why would that be Lockout Tagout or not Lockout Tagout? And what the Lockout Tagout standard is referring back to, that it doesn't apply to the control of hazardous energy, then it falls under the machine guarding standard. What does this really mean? You have to take a look and document every task that is performed on a piece of equipment. It's a task-based analysis. Decide what needs to be locked out and tagged out for that particular task, or if it's a machine guarding aspect. If it's a machine guarding aspect, you have to have the proper machine guarding and safety system in place for it to take effect. But what happens when you don't know? The best phrase is, when in doubt, lock it out. If you don't know you have an effective safeguarding system, how do you ensure employees are safe at that point in time? When in doubt, you lock it out. You do lockout, tag out, and you make sure that your employees are properly trained, whether it be authorized or subject to being around lockout, tag out procedures. Everybody needs to be effectively trained per OSHA specifications as well. So, what are the issues? What do you need to know, and how do you do it before you actually apply it? Here's a couple of the bullet points, a couple of the things that you should be looking at. It's always easy to say that a task is normal production, so that falls under guarding. It makes it a convenience factor. You do not want to do it out of convenience because that's the way we've always done it. Just because you've always done it that way doesn't necessarily make it the correct way. Is that task, should it really be under a lockout tag out condition versus machine guarding? Maybe you do justify it as a normal, routine, repetitive, critical for production, whether that be minor servicing or simple little task on a machine, but you don't have a proper safety system to begin with, then it should fall under lockout tag out. The next thing is, understand the equipment, understand the machine. You saw the words unexpected startup or applying energy back to that machine unexpectedly. Understand how that could possibly happen. Probably one of the most common aspects to that unexpected startup would be trapped pressure. When you're doing a task such as clearing something out of a machine, whether it's a cleanup process or a changeover process, whether it's lockout, tag out, or machine guarding for that particular task, is there a possibility that a trap pressure or a mechanical load, that if an operator sticks their hand in that machine and somehow releases that, a cylinder takes off, whether it be hydraulic or pneumatic, or something was mechanically held, but it had spring tension on it and the spring gives way? That's unexpected startup. In cases like that, that's why it's part of the lockout tagout procedure that residual pressure or trapped load or trapped hazard is removed with the lockout tagout procedures. If it's going to be machine guarding, how does the machine guarding circuit remove that trap pressure? So if I open up a door, is it dumping the air? Are there open center valves where everything bleeds out, that there's no stored energy in that system that can cause that unexpected startup? What does the current guarding and safety circuit do? This is critical. This is a big piece that may or may not get missed in different organizations. You may have a safety system that is attached to the machine. Is it the correct safety system? If your safety system needs to be control reliable or a Category 3, Category 4 system in architecture and design where you need redundancy and monitoring on the door switches or light curtains or the output contactors or a safety dump valve, a safety rated dump valve, do you have all that in the system based off of the risk assessment? Your risk assessment is going to help you determine that, but how can you effectively rely on guarding when you need a dual channel system, but your machine only has a single channel system. Maybe your risk assessment says a single channel system is okay, but you start with your risk assessment in a case like that. So does the guarding meet that proper safety levels per the risk assessment? Do you have all the right guards in place, whether they're mounted at the proper safety distances? Do you have effective guarding that's working on the machine and effectively protecting the operators at that point in time? Now here's the big one too. How does any company define or interpret minor servicing? I wish I can give you a direct black and white answer and give you that magic bullet that would solve all those issues. The best thing I can tell you is you need to document what is normal, routine, or repetitive, and what is considered minor servicing in your eyes, because every company is going to be slightly different for the sole purpose is they have different equipment. Even within the same organization where you have multiple facilities, one facility may be more automated assemblies where another facility may be converting type of equipment, but it's all under the same company umbrella. Minor servicing could be different, and each piece of equipment is handled differently. It could be different within one facility in one building. You have different pieces of equipment. You need to truly document what is normal routine, what is minor servicing, and have that document. Because even when you have an inspector come in, right away the thought process is to go right toward lockout tagout unless you have your documentation that proves and justifies what is normal routine or minor servicing. If you don't have the documentation to support it, one way or the other, how do you give justification to anybody, whether it be an OSHA inspector, a lawyer if you're caught into a lawsuit, a third-party auditor? How do you get that justification if you don't have the documentation to back it up? You can't just say, well, that's the way we've always been doing it. Where's your justification? Where's your documentation as a result? So what we broke it down to is into 3 actions. First is put your task-based assessment or your task-based risk analysis into place. Have each piece of equipment review all the tasks associated with that piece of equipment and make a determination after you define normal, routine, repetitive, and minor servicing. Make a determination for each task. What bucket does that fall into? Does that fall into the lockout tagout bucket, or does that fall into the guard interlock bucket, the safeguarding bucket? Once you're able to get your task-based assessment done, you know what tasks fall into which criteria so you can effectively train your employees on following proper procedures as well as safe work practices or work instructions. But in conjunction with that, the next 2 steps are critical as well. First off, do you have proper lockout tagout hardware and procedures? Are they documented? How many sources of energy does a particular machine have? Lockout tagout isn't just isolating the 3-phase 480-volt power that's running into the machine. Maybe there's multiple power sources where you have a 120 as well as a 480-volt source because that's what the machine requires. Maybe you have a UPS, a battery backup system that needs to be locked out to ensure a safe condition as well. What about fluid power, hydraulics and pneumatics? What about mechanical lockouts? For example, if you have a press where you have to hold the press in the upstate and you're taking away the hydraulics and pneumatics, but now you have gravity taken over, do you have mechanical lockouts that prevent something from moving and starting up that can cause serious injury or fatality? With all those points, you need to document what the lockout tagout procedure is, but where are the lockout points? How do you perform the lockout? How do you check that? That's all part of the lockout tagout procedures. Make sure you have all the proper hardware to perform effective lockout tagout on a piece of equipment for the tasks that require that. The last part is proper hardware and circuitry for your machine. And what we're talking about is the actual safeguarding itself. Whether it be a mechanical guard with swing doors that require interlock switches, do you require safety controllers, programmable safety controllers, safety PLCs? Do you need mats, light curtains? Do you have redundancy on the outputs where you have redundant monitored hydraulic valves, safety pneumatic dump valves, redundant mechanically linked or mirrored contactors to ensure the motor enters a safe shutdown condition? You need to make sure you have all that proper hardware when it relates to machine guarding as well. You need to have the proper wiring. You have to look at the safety function as a whole, from the triggering device to the moment it's switched off. By relying on that guarding, are we effectively protecting people to perform their normal, routine, repetitive tasks? So let's talk a little bit more about the task-based assessment. You're identifying all the different tasks, but it's not just what the operator does. I know companies are different out there. Some companies, if a task falls under a lockout tagout, it's automatically a maintenance functionality. The operators are not authorized to do lockout tagout. They're made aware, but they're not authorized to perform lockout tagout. Other companies, there are certain tasks that operators do that they are fully authorized and trained to perform lockout tagout. But whether they're authorized and trained or whether they're allowed to perform lockout tagout or that's a maintenance functionality, they're performing tasks on a machine that requires machine guarding. You need to document that and determine that to ensure that, but you're not just thinking about the operators. It's the task of the operators. What about maintenance personnel? Not just fixing a machine, but when they're trying to troubleshoot a machine or make minor adjustments, would that fall under the minor servicing, or does that fall under lockout tagout to make those adjustments? Again, it comes back to each piece of equipment is going to be unique and different, and you have to document and justify that. What about engineering? Does machines have setup modes? Well, setup modes could be completely different. How do you set it up? Is that normal routine, or is that more along the lines that the machine jammed enough where you had to do a reset up, and that setup should be under a lockout tagout condition? Your task-based assessment should address that and look at it. You make that determination for each task for anybody that has to work on that piece of equipment, from operators, maintenance engineers, or anybody else associated with that facility. Could be mechanical techs, service techs, line techs. Who has to do that? It could be supervisors that do more of a setup, or set up people versus operators run the equipment. Again, every company I know is different, and you need to fall into that area. So here I kind of put a bucket down. We have the lockout tagout bucket on the left. We have the machine guarding bucket on the right. And I just listed some simple tasks in each one of those. And I'm going to say most of the time, again, it depends on the equipment, but most of the time when you see some of these tasks, such as under lockout tagout, replacing a transmission chain or a belt pulley, changing a cylinder out because maybe the cylinder rod got bent up, damaged, it blew a seal, doing some preventative maintenance where you have to remove a cover. Again, when we go back to that definition, once you remove a guard, it's under lockout tagout. You have to lubricate a chain and sprocket that's coupling a motor to a conveyor, for example. That all falls under lockout tagout. Changing saw blades, replacing components in an electrical cabinet, such as a burnout relay or a contactor. There could be hazardous voltage. It has to be under a lockout tagout condition. Well, we go all the way to the right under the machine guarding. Some of the basic operator functions could be, hey, they're just loading materials in a hopper. If I open up a lid It stops the hopper, load the raw materials, close the lid again. Maybe the hopper is open and there is no hazards that the operator can get to or reach into because it's effectively guarded through mechanical guarding. That's a normal machine guarding operation. Hey, you got a loaded part in a press. Well, just because it's a manually operated press, well, you're unloading and loading parts. We're not going to lock out and tag out that press every single time somebody puts their hand in there to remove a part or load a new part in there. That's what your safeguarding's there for, whether it be a door or a light curtain that you see on presses or two-hand control that you see on presses. That's the safety function. That would be a normal, routine, repetitive type of task. Refilling labels on a printer, a label printer. Adding ink, such as printing presses. Analox rollers need to keep on running, but if the Analox rollers and the trays are effectively guarded, hey, the printer can keep on running if you got a spout to be able to fill ink up, or if you have to open up a door, you stop the Analox rollers, fill up the ink tray, close the door again because it's interlocked. You can proceed with your normal operation and minimize downtime, maximize your uptime. We all want to be producing and making money, but how do we do it effectively, efficiently, and safely at the same time? Now, what you see in the gray box in the middle, you see the title is Lockout, Tag Out, or Machine Guarding. These are some of those steps that can go either way. It depends on the company. It depends on the interpretation. For example, clearing a product jam. Well, a lot of times people may think, well, if it's a jam, it's under a lockout tagout condition. And maybe 60, 70% of the time, that could be the case. It depends on the piece of equipment. But in other cases, such as you're dealing with converting equipment or equipment that deals with fabric or textile type of thing, it doesn't always go in the same place. It's not always consistent. Humidity changes in the air. It changes how the machine operates with the material. You get constant jamming. Some facilities may determine that clearing a product jam is a normal, routine, repetitive, critical for production, because every time they lock out and tag out, it's 30 minutes of downtime, but they're clearing jams once an hour, once every 2 hours. It's critical for production. How do you effectively ensure that they're safe under machine guarding? The first point I want to make with something like that is having the proper safety circuit, the proper switches, light curtains, safety controllers, based off of the risk assessment, as we said earlier. That's number one. Number two, it really comes down to, in clearing that jam, you have to understand, which comes back to your task-based analysis, and understand what unexpected startup would be on your particular piece of equipment. Because let's say that material jams. Well, everything, when you open up the door, removes pressure, there isn't any stored energy, that may fall under a machine guarding aspect. But if that jam has caused something to trap pressure, let's say it's a pneumatic cylinder that caught the material. Well, the pneumatic cylinder did not get normally dumped with the machine guarding. So if I go and clear that jam, and all of a sudden that cylinder starts moving, which it could catch, pinch, cut, or amputate my finger, that's not machine guarding at that point in time, because there was an unexpected startup that could occur. You have to prevent that. So if you're going to rely on machine guarding to clear that jam, you have to ensure that, one, you document and justify that is a normal, routine, critical for production type of task. Two, you have to make sure that the jams that you're talking about will not allow an unexpected startup to occur as a result. Because, in simply putting, you have to provide equal or better means of protection as what Lockout Tag Out is doing with energy isolation. You need to do that same thing to perform those necessary tasks. Doing line changeovers. Some line changeovers because they require a tool. Some companies view it's a tool. I'm doing a changeover. It needs to be under Lockout Tag Out. Other machines, such as in the food industry, you're doing a line changeover, or pharmaceutical industry, you're doing a line changeover. Well, part of that line changeover is you're changing a product size, a box size, a bottle size, and you may need to run that bottle to go through and do that changeover. But you have the procedures, you have the safety circuit behind the scenes to ensure that people are not getting into an unsafe condition. We get controversy with die changes, whether it be in a punch press or just a hydraulic press, a mechanical press, changing the dies out. Reality is, because you're taking a tool and you're physically removing dies, it should be under a lockout tagout condition. But sometimes with presses, what you have to do is you actually have to operate the press, close it, and you have to remove the bolts that hold both halves of the dies to either the ram or the up-acting cylinder or down-acting cylinder. And then to go and do lockout tagout, remove the bolts, go back and remove lockout tagout just so you can open that ram back up again to go back and do lockout tagout. It's not a very production-friendly tool where if you have effective machine guarding, that allows you to do effective die changes. And again, I'm just giving examples. It doesn't mean it works for every company. You have to look at each company in particular and each machine. But doing that where you can apply effective guarding that prevents that ram from moving, because when you have that ram up and you break that light curtain or you open up that door and you put that die block in there as an extra means of mechanical support in case pressure is lost, at that point you can rely on your machine guarding. But again, you need to justify that, and you have to follow the regulations such as what's laid out in OSHA 1910.217 for power presses. Okay? Maybe tensioning of a belt. You may not be exposed to a hazard, but when you're adjusting apparatus, mechanical apparatus, is it just lifting up a cover such as if you see on a typical drill press? As long as that cover is interlocked, you can open up the cover, it shuts it down. You can change the pulley speed by adjusting the belt, close the cover again, hit a reset, allow the machine to start back up. Maybe that falls under machine guarding. Otherwise, it would fall under lockout tagout. So here's where you can see that there could be a good amount that falls under that in-between, that gray area state. You have to make that justification internally. Do not justify for convenience. Justify out of function. Understand what that unexpected startup could be. What is normal routine? And I'm sorry for repeating that, but that's what we have to hit home. Knowing what's normal, routine, repetitive, and what you can do with machine guarding and having an effective machine guarding system. So by putting it together, we have our processes and procedures. We have a proper disconnect switch. We have a proper shut-off valve that we can lock out or the accessories for that valve and perform that function, which then leads to ensuring that you're taking away all forms of hazardous energy, your electrical, your hydraulic, mechanical aspects, mechanical springs. How do you safely remove stored energy? For example, some machines you may load lock, such as a hydraulic cylinder. You may load lock that cylinder into place to ensure a safe condition where there's trapped pressure in the system. But in order to perform a maintenance function on that, whether it's doing a PM to replace a hose or look at the cylinder where you have to do a repair on the cylinder, how do you safely dissipate that energy? Do you have stored accumulators in hydraulics or pneumatics? How do you safely dissipate that energy? Is there a manual bleed-off valve? That has to be part of your lockout tagout procedure. Who's authorized? Who's trained to do it? Make sure that's documented. What is your testing procedure to make sure your lockout tagout and your isolation is working? Is it trying to restart the equipment? Do you see anything move as a result? Where is the equipment to implement Lockout Tag Out? And what I mean by that is if you have additional devices such as locks, such as the hasps that go onto a circuit breaker, things like that, where is that equipment kept? Who has control of that? Is there Lockout Tag Out stations? Is it assigned to personnel? Is it assigned to specifically to that machine? Know where that's at and where the procedures are posted at. Where are they kept? Ideally, you want the procedures posted at the machine. It's not always possible. Do people have quick, easy access to getting to that procedure? Next comes that point with proper hardware and circuitry for machine guarding. If you know, based off of the risk, where you have an amputation, a fatality type of risk, you go through your risk assessment process, you need redundancy and monitoring. If your system only has a single channel, I don't care what you determine for your task, everything really should fall under Lockout Tag Out because you cannot effectively rely on your safeguarding to protect people from serious harm if you don't have the right safety system in place on your machine. You get the right safety system in place, you can now use the machine guarding for the tasks you've determined during your task-based analysis. Okay, and continuing with that, what do we mean by the proper hardware? Safety-rated devices, whether it be a light curtain on the front of a machine or a hard guard that needs to be locked where you put a locking switches. Your e-stop considerations. What do you need to do? How are those safety functions determined? Because you really should be looking when you do your task-based analysis, do you have that core understanding, and I'm going to say that 10,000-foot view of what is the safety function, what does it do, how does it do it, what's supposed to put the machine into a safe condition, the motor's supposed to shut down, how's that being done? If you're using guarding for that, are you removing that hazardous energy that has to be taken in consideration that's exposed to the operator performing that particular task? Are you doing that with guarding? So why do we have these issues? Too many times we see that there are no procedures put into place, or procedures were put into place and nobody can find them, they're out of date, machine's been changed, it's been modified, they're missing the procedures. Training is a huge one. People are not trained. The lack of the safety circuit, not having good guarding, not having the documentation, or assigning the task. You didn't have justification. Nobody did the task-based analysis. It just came at, oh, yep, this task is Lockout Tag Out. Oh, no, we've always done it this way. This has to be machine guarding. So how do you move forward? We look at the Lockout Tag Out, hardware, procedures, removal, source of energy, train, and audit. Audit is a big one. You want to be able to go out to a machine and pull out a procedure and review and observe the tasks in both Lockout Tag Out as well as machine guarding with the deal with SOPs. Are they performing that task safely? Are they doing all the proper steps? Are they following it? If they're not, you get down to the root cause. Why? Is it because something changed in the machine? A new product is run, but the procedures weren't updated. You can capture that, but you audit that process to make sure it's effective. When you look at machine guarding, did you do your proper analysis? Did you identify and figure out what the safety functions are related to each piece of equipment? What are the safety functions on that particular machine? E-stop, guard door interlock, a muting light curtain. How do you ensure the safe condition once you trip that device? Is it redundant contactors? Is it a safety dump valve? Make sure whether you need a performance level C, D, or E, or a category 3, category 4, control reliability, whatever you're following, do the circuits meet that criteria? Are you designed and installed to a proper safety level? And where do you know there's unexpected startup the machine guarding needs to be able to pick that up to protect operators. And then the last part is that task-based risk assessment, identifying the task, supporting it, justifying it, not out of convenience. Do that routine checks on all systems, do that audits, review, examine, observe, and make sure they're being followed. I know it's a big job, but when you have that procedures in place and you have that all determined, you got your easy justification, and what I think you're going to find is accidents resulting from the lack of lockout, tagout, or machine guarding will going to start diminishing because of proper procedures being not only being followed, but the devices are there to be able to do it and do it effectively as a result. The last thing that I want to cover with you guys is there is something in between, and this has been around for a while. It's not actually written into OSHA law. You will not find it in 1910.147. There's an ANSI standard out there, ANSI Z244.1, that's been out for quite a while now, and it's taken time for more and more to be adopted from that. But back in 2008, OSHA released an updated inspection manual for Lockout Tagout for their inspectors, and that manual allows inspectors to accept alternative measures and principles to Lockout Tagout for Lockout Tagout functions. This gets a little scary sometimes if you're not familiar with it, but what this is actually using the safety system to perform Lockout Tagout. When you think about the amount of time and the way to verify and ensure that you removed all forms of hazardous energy, you may be hitting 3, 4, 5, 6, 10 different lockout points on a machine that may take a half hour, 45 minutes to follow all that procedure to do what is a 5-10 minute job, and then take another 45 minutes to remove everything, put everything back into place, get everything started back up again. You have a significant amount of downtime. Well, if you have an effective safeguarding system, you can combine the two and get on certain devices for manufacturers, you can get lockout tagout ability devices to lock out an e-stop or lock out a door switch like you see in some of the pictures on the bottom of that slide there. What that's for is if you have, one, a proper safety system that removes all forms of hazardous energy and provides equal or better means, which pretty much you're looking at redundancy. So if you have, let's say, 3 sources of energy, you have hydraulic energy, you have a pneumatic line feed from house air, you have 480 volt 3-phase power feeding the machine. I have 3 separate lockout points, but if I can use a guarding system that will redundantly, with monitored, mechanically linked contactors used for safety, I can redundantly isolate the 480 volt 3-phase power. I can get control reliable category 3, category 4 safety dump valves. I can isolate the power to the hydraulic power unit. I can put redundant monitored hydraulic valves to basically take away the pressure and recircuit back the tank and bleed off the pressure and take it back to tank of all the cylinders or the hydraulic system under that lockout tagout. If my safety system does that, and I can justify alternative lockout tagout procedures, I may be able to use the machine guarding system and perform lockout tagout with this if there is no unexpected startup, and that's the key to it. Now, companies are going to have different opinions of alternative lockout. Some companies accept it. Some companies do not accept it. It's okay either way whether you do or do not. You're not forced to follow alternative lockout. What you do need to do at a minimum is have your task for your lockout tagout with an effective system, have your task for your machine guarding, and have an effective system as well. So we just reviewed that summary. Have proper hardware and procedures, have the proper safety system, document and justify, and if it's something you don't know, go right back to when in doubt, lock it out. So at this point, I think we're at a point where we can start taking some questions.
All right. Thank you so much, Mike. That was great stuff. So a lot of you have already submitted some questions, so we're going to jump right in. So while our presenter is answering your questions, please just take a moment to complete the feedback form that appears on the left side of the screen. All right, Mike, so question number one is, when one buys a machine, or even before purchasing it, how does the buyer know what level of protection the safety circuits meet?
Well, the best thing that I can recommend for anybody that's buying a machine, depending on whether it's a small, I'm going to use the phrase cookie cutter, a small cookie cutter machine you buy out of the catalog, versus a custom piece of automation that a lot of times may get bid out against multiple OEMs or machine manufacturers. You want it specified in your bid proposal. The more you can document it up front before you actually place a purchase order with somebody, you want to find that information out. How are you going to get that? What's going to make that determination? Who's doing the risk assessment? Some manufacturers are having their machine builders do the risk assessment. It should be a combination. The machine builders should be performing the risk assessment on their equipment to the best of their ability, and it should definitely be backfilled with a risk assessment by the end user of that equipment to make sure they have all that and they want to review that. So if you think about, most EHS professionals are not controls engineers. EHS professionals are expected to do a lot. One of the things they're not expected to do, or they may be expected, but it's not realistic, is to read schematics. They need to rely on their controls or electrical engineers to read the schematics to help them determine that they've met the proper safety level per their interpretation as a company. If you cannot do that internally, that's where you may get a third-party engineering and have somebody like us come in there and help you bridge that gap to make sure you're getting what you need. What happens if the machine needs to be modified, but the OEM doesn't want to do it? That's up to you to make that decision. Do you still buy that piece of equipment and then modify it, or do you go somewhere else and go to a different piece? I want to say in today's world, I think a lot of OEMs will do what they need to do to try to help you out because they want to put out a safe system as well. But it really depends what your knowledge and your base is.
All right. Next question is, when you're talking about normal, routine, and repetitive tasks that might be covered by machine guarding, is there any kind of time limits that are considered reasonable for these tasks?
Nothing that I have found. I'm not saying that there's nothing out there in the interpretation letters, but there's nothing that states that in, particularly in the OSHA standard, being 1910.147. Nothing with the timing factors that I can give any kind of hard numbers, and unfortunately I'm going to revert back to what I said earlier. Every piece of equipment is different, so it really depends on that task. So as a company, when you look at that piece of equipment, if that task requires a lot of longevity to it and access, but part of where that's found is when you do your risk assessment. When you do a risk analysis on a piece of equipment and you identify those safety functions, you're looking at a few factors when it comes to the safety circuit, 3 in particular: the severity of harm, the frequency of exposure, and the possibility of avoiding it. So part of what you look at is when the frequency of exposure, such as if we follow the chart laid out in ISO 13849, we have S1, S2, F1, F2, P1, and P2. I'm not going to go in details in the other aspects, but the particular one, based off of this question, is frequency of exposure. based off of a combination of 13849 as well as TR 14121, which is a technical report. They identify frequency as being, if you're getting into a machine once every 15 minutes or more, it's considered frequent. It's a high exposure, which means you need a higher safety level. If you're in there an accumulated time that's at least 1/20th or more of the total operating time, they're considering that frequent. So the decision of being infrequent versus frequent is going to help determine what safety level you need. So you may find a task that you're in there for 10 minutes, just because it's 10 minutes versus 1 minute doesn't necessarily put it into a lockout tagout bucket. It just means that you have the proper safety circuit that maybe instead of a Category 3 circuit, it puts you into a Category 4 type of circuit where you have additional monitoring, different components, and things like that that takes you to a higher safety level, but that's the requirement based off of your risk assessment. So I wouldn't say time doesn't play a factor. It certainly does, but there's no hard numbers that I know of that tells you you must do lockout tagout if you exceed this.
All right, next question. Is a lockout tagout required for adjustments and tool changes when guarding is not installed, for example, with vertical manual feed mills?
Well, if you go back to the application of the standard, when you look at the application section of OSHA 1910.147, there is in there that it talks about when it's covered, when it's not covered. So when you don't have any guarding and you're doing a tool change, how do you prevent that machine from unexpectedly starting to fire it up? You need to perform lockout tagout doing tool changes in a case like that. How do you prevent that when there's no guarding? And what was the example that you brought up there? What type of
vertical machine milling?
So vertical mill. I know with the mills, a lot of times they just flip the switch off. They put a tool wrench. They lock the spindle so they can just do a quick tool removal. You know, part of that is maybe that's part of procedure. Do you define that as normal, routine, repetitive task that lockout tagout is not required? But what other additional guarding? Because there should be some level of guarding, such as a chip shield cover. Maybe you have a safety switch on it, so when they remove the chip shield cover or flip it out of the way, it breaks the safety circuit, which ensures that the motor is in a shutdown condition and you cannot have an unexpected startup, whether it be a switch failure or a power failure causing it to start back up again. So I hope I answered that question properly for whoever asked.
And we can always follow up after. Next question is a good safety question. So troubleshooting is always a problem. What if an employee needs to enter a machine danger zone to troubleshoot because it's impossible to troubleshoot outside of the danger zone?
All right. Ooh, this is going to be a tricky one. The issues you have, I would go back to the drawing board and look at step one. And step one being is the question stated in it, it's impossible to do from outside the danger zone. That's not always the case. It may be told that it's impossible, but I'm not saying it's not. It very well could be that you need to troubleshoot while inside the danger zone. The first step is, how can I do this outside the danger zone and still effectively troubleshoot it? Some of the reasons, and this actually has partly been addressed in one of the latest standards, ISO 14119, where they talk about the motivation of defeat of guarding. It might be that being outside the danger zone is because maybe there's solid sheet metal panels, or I just can't see how the machine's operating, so the guarding gets removed or somebody places themselves in there so they can see what's going on. How about adding some design characteristics such as visibility to getting in there? So there's certain things you can do. The next step you would do is, let's say you have to be in there. Follow the concept of what the robot industry has done. For example, teaching a large 6-axis robot from outside of fencing 15 feet away is next to impossible to do. There are certain criteria that you can go inside a cell and teach a robot. You need to have a pendant station that has an e-stop on it. It has a 3-position enabling switch. The robot only can run at a speed slower than 250 millimeters a second. There's certain criteria to allow you to do that. If you're going in to troubleshoot a machine, is there a way that you can give, let's say it is impossible that you have to be in there, you have to have a guard door open for troubleshooting. Determine if it's convenient or need. If it's convenient, you close the door again. If it's need, what additional measures can you provide somebody like maintenance who's already authorized to take a little bit of a higher risk, for lack of better words, and give them some tools to help reduce the overall risk in your risk assessment process. Part of it might be putting 2-hand control. They can only jog the machine at a limited speed or a limited motion. Monitoring that speed and motion behind the scenes safety-wise when you're in that particular mode. Maybe they have to have a hand-free for adjustment. Put a 3-position enabling switch in their hand with a jog button. Maybe it's a 3-position foot pedal switch. Doing a delayed start on the machine in that particular mode. Not only reducing the speed, but hey, hit that jog button or hit that go button. It can only run at this speed, but it's going to wait 2 or 3 seconds. It's going to send off a buzzer and a flashing light to say this machine is about to move in this condition. Only accessing one area. It should never be a case where somebody goes into a cell, closes a door, and an operator outside the cell, and he tells them to go ahead and start the machine. That is completely unacceptable. How do you get around that in design? That's going to cost money, but that's how you effectively safeguard and be able to do something. It may not be perfect, but it's certainly better than exposing anybody to hazardous situations with full free automatic running.
All right, and we have time for one more quick question. How does the minor servicing exception apply to operators versus maintenance personnel?
That all comes back to different companies. And what I mean by that, I said earlier, some companies, if it's Lockout Tag Out, it falls under maintenance. If it's not, it falls under operators. But what would be considered minor servicing at that point? You have to justify minor servicing because there are operators that they are not only running the equipment, there are companies out there where the operators are also doing preventive maintenance on the equipment. So they're kind of operators and maintenance and doing minor servicing tactics. I wouldn't necessarily focus on whether it's an operator or maintenance, but when you do your task-based analysis, it doesn't matter whether it's an operator or maintenance. Whoever's performing this task, this is a lockout tagout task or this is a machine guarding task. That's what you're driving down to when you define minor servicing. But if an operator is going to perform that minor servicing task and you've authorized them, you have to ensure that they're trained in performing that task. How do you know that the machine guarding is working properly? How do you check it? How do you perform that task safely? Because minor servicing might be considered clearing a jam. It may not, but every company needs to make that decision. So I apologize for not being able to give a direct, distinct black and white answer there, but it really depends on the company, the machine, and what people are authorized and trained to do. But it ultimately boils down to looking at the task and determining what does the task need, lockout, tagout, or machine guarding.
All right. Well, I am afraid that we've run out of time. I'd like to thank Mike DeRosier and our sponsor, Schmersal. Thanks again for joining us for this webinar, Lockout Tagout versus Machine Guarding. As a reminder, if you are registered as a group, please add the names and emails of everyone in attendance on the exit survey. On behalf of us at NED, EHS Today, and Machine Design, we hope you have a productive remainder of your day. Thank you.
Thank you, everybody. Have a great day.